Okay, welcome back. We are continuing differentiation. For those of you that have not watched my other videos, I would like you to watch it. But before we continue, I would like you to like and subscribe. Today, we are going to be looking at differentiation, and the part we are going to be looking at is chain rule. We will look at chain rule and product rule. We're also going to look at potent rule. Potent rule. We'll look at these rules fast as possible. Now, the first one we are going to be looking at is chain rule. Chain rule is also known as function of function, meaning is a function that has another function in it. Function of function. It's a function that has another function in it. What do I mean by that? Remember, the formula for chain rule is dy over the x will be equals to dy over the x multiplied by the y over du, I mean to say multiplied by du over the x. If you look at the formula for the chain rule, when you cancel this part, you are still going to have your dy over the x. Let's look at a typical example of a chain rule. You have y is equals to 2x squared plus 5 raised to power 3. This is a typical example of function or a chain rule. We have a function inside that have another function. What do I mean by have a function that have another function? Remember, in differentiation, we usually subtract 1 from the power and use that power to multiply the equation. Now, the question now is this. We have 2 power here. Which of the function are we looking at? Are we using the power? So now you are going to take one of the function and call it u. So our u now will now be 2x squared plus 5. If our u is 2x squared plus 5, our y now will now be u raised to power, it's 3, I mean to say. Our y now will be u raised to power 3. So now I'm going to differentiate u with respect to x, which is this one here, which will give me, following our rule, will give us 4x. Then I'll differentiate y with respect to u, which is this one here, will give us 3u squared. Now that we have our u over the x and the y over the u, then we can apply our formula. We say dy over the x is equals to dy over du multiplied by du over the x. So now our dy du over the x is 4x multiplied by 3u squared. So when you multiply them out, you will have your dy over the x will be equals to 12, will be equals to 12x u squared. But you not leave your answer here. You must put back what your u is. So you don't have 12x in bracket 2x squared plus 5 raised to power 2. And that will be your differentiation of that function. I can give more example, but this is just a typical one. I can have example that is in form of y is equals to square root of 3x squared plus 2x. Now, this one is also a function that is inside another function. This is the same thing as your u now will be equals to 3x squared plus 2x. You agree with me that y is also the same thing as 3x squared plus 2x raised to power minus 1 over 2, a typical indices format. So if that is the case, our y now becomes u raised to power half. So if I differentiate my u with respect to x, I will have 6x plus 2. And if I differentiate y with respect to u, I will have half u raised to power minus half. Because when you minus half from 1, it will give you minus half. So now when we put our dy over the x, following the formula now, we are going to have 6x plus 2 multiplied by 1 over 2u raised to power 1 over raised to power half. So our answer now will be 6x plus 2 all over, if you follow because of law of indices, 2u raised to power this. So if you simplify it more, our dy over the x will now be 6x plus 2 all over 2 root whatever u is. So what is our u again? 3x squared plus 2x. 3x squared plus 2x. This can be simplified more. Your dy over the x will now be 3x plus 1 all over root 3x squared plus 2x. Very easy to apply. I would like you to try it out, experiment it on different ones. The next video I'm going to be sending is going to be on product rule. Try to watch that one too. Thank you.